Now we'll see some problems coming in this portion, that is based on properties of DFT, how will you solve problems. Now this is the first one. If the DFT of x of n equal to x of k, find the DFT of x of n minus 2, x of minus n, x conjugate n, x of n, circular convolution x of n, and finally signal energy. Now your x of k is given. Now x of k is given as, now this is given in the question, 4 minus 2j 0 2j. Okay. Now first one you have to find x of n minus 2. Now when you see the signal x of n minus 2, you can immediately understand that it is based on time shifting property. Now this is, signal is shifted by 2 units, so you just apply time shifting property for the signal x of n. You will be getting x of n minus 2. Okay, so we know x of n, DFT of x of n is x of k, then DFT of x of n minus 2 will be equal to x of k into e raised to minus j 2 pi divided by n k into 2. This is time shifting property of DFT. That means if a signal is time shifted by m units, then the DFT will be equal to x of k, that is DFT of x of n multiplied with a factor e raised to minus j 2 pi divided by n k into 2. And what is n? N is the length of the given sequence. So here n is equal to 2. So n is equal to 2 means this will be equal to x of n minus 2 will be equal to what? X of k e raised to minus j 2 pi divided by 4 k into 2. So this is equal to x of k e raised to minus j pi by 2 into 2 becomes pi into k. So what is the DFT? DFT of x of n minus 2 will be equal to, first is x of 0 e raised to minus j pi 0, comma x of 1 e raised to minus j pi 1. Now x of 2 e raised to minus j pi multiplied with 2. Then x of 3 e raised to minus j pi multiplied with 3. Okay. Now what is x of 0 is equal to x of 0. Sequence is x of k 4 minus 2j 0 2j is the sequence. So what is x of 0? X of 0 is 4. 4 into e raised to 0 is 0. 4 into e raised to 0 is 1. In comma x of 1 is minus 2j into e raised to minus j pi, that will be minus 1. Then third term x of 2 e raised to minus j pi into 2, third term is 0, so that becomes 0. Then x of 3 is 2j here, so it is 2j e raised to minus 3j pi, that will be minus 1. So what is the sequence now? 4 2j 0 minus 2j. Now this is the DFT of x of n minus 2. Now second, what you have to find? Second is you have to find the x of minus n, DFT of x of minus n. So second one is DFT of x of minus n. Now you can see x of minus n is coming. So what property you have to apply? You have to apply time reversal property. This is time reversal property. So you can write DFT of x of minus n will be equal to x of minus k. Now there is a property, that is DFT of any real valued sequence x of n is x of k, that can be equated to x conjugate minus k. Similarly, x of minus k will be equal to x conjugate plus k. Now the proof of this you can find in the textbook, Anand Kumar, DSP by Anand Kumar, page number 435. Okay, so this is the proof. That means for any real valued sequence x of n, x of k is equal to x conjugate of minus k, and x of minus k is equal to x conjugate of k. Now here when you apply time reversal property, DFT of x of minus n, you can directly write it is equal to x of minus k. Now how will you find x of minus k? That can be using this property. You can equate this equal to x conjugate, x of minus k is x conjugate k. So you know x of k. Now you take just the conjugate. So x of k, you know it is 4 minus 2j 0 2j. So now what is the conjugate? Conjugate of 4 minus 2j. So x conjugate k means 4 minus 2j 0 2j conjugate. How will you take the conjugate? So this will be equal to 4 2j 0 minus 2j. Okay. So this is the DFT of x of minus n. Now next is you have to find DFT of x conjugate n. So this again you can apply the same formula. X conjugate n is same as, this is conjugate symmetry or complex conjugate property. Complex conjugate property. X conjugate n is equal to x conjugate minus k. This can be equated to x of k from this one. X conjugate minus k is equal to x of k. So x conjugate minus k, you can write it as equal to x of k. So DFT of x conjugate n is equal to x of k, that is the same sequence will come 4 minus 2j 0 2j. So this is the answer for x conjugate n. Now next one is what you have to find is DFT of x of n convolution x of n. So DFT of x of n convolution, circular convolution x of n. Now using a convolution property, you can directly multiply the DFT of x of n. So here it is x of n convolution x of n. So you can directly take x of k multiplied with x of k. If it is two other signals, x1 of n and x2 of n, then here it will become x1 of k and x2 of k respectively. So you just multiply the two sequences 0 2j multiplied with 4 minus 2j 0 2j. So when you multiply, this is 16 minus 4 0 minus 4. So this is how you find convolution of DFT of two convoluted signal.